Welcome back, dears, to the next chapter, Ray Optics and Optical Instruments from Part 2 Physics. In this module, let us discuss about the refraction of light. Refraction is the phenomenon of change in the path of light as it travels from one medium to another, when the ray of light is incident obliquely. It can also be defined as the phenomenon of change in the speed of light from one medium to another. Now let us discuss about the laws of refraction. The first law states that the incident ray, the normal to the refracting surface at the point of incidence, and the refracted ray all lie in the same plane. According to the second law, for a given pair of media and for light of a given wavelength, the ratio of sine of the angle of incidence to the sine of the angle of refraction is a constant. Or refractive index mu is equivalent to sine I by sine R, where mu is the refractive index of the medium, I is the angle of incidence, and R is the angle of refraction. This equation is also known as Snell's law. We had already studied about the refraction of light through a rectangular glass slab. So let us view the incident ray, which is incident obliquely on one of the surfaces of the. If you are drawing a normal to the surface, it is making an angle of incidence of 30 degree. The ray inside will bend a little towards the normal as it is passing from air to glass, or from a rarer to a denser medium, it is bending towards the normal. When the ray EF reaches the second surface DC, it again gets refracted. Fs represents the emergent ray. So, from the figure, it is clear that the angle of incidence and angle of emergence are the same. And if you are extending the incident ray, we can see that the incident and emergent rays are parallel to each other. And this distance between the incident and emergent ray is known as lateral displacement. We know the emergent ray will be bending away from the normal as the light ray is passing from glass to air, or from a denser medium to a rarer medium. Now let us discuss about the refraction of light through a triangular glass prism. Let us take a triangular glass prism ABC. Let this be an equilateral triangular prism. That is, angle of the prism is equivalent to 60 degree. Angle of the prism refers to the angle between any two of its lateral faces. Let the incident beam be incident at an angle of incidence of I towards the face AB of the glass prism. Then we know it will undergo refraction. The ray inside the prism will again bend as it reaches the surface AC of the glass prism. Now you can see the emergent beam of light coming out of the prism. If you are extending the incident ray forwards and emergent ray backwards, you can see that there is a deviation in the path of light ray. That angle measured is known as the angle of deviation, marked by D, or the blue shaded portion of the prism. Now there are two refractions inside the prism, and these refracted angles are represented by small r. Angle of emergence is marked by the letter small e. From the figure, it is clear that in the quadrilateral APOQ, angle A plus angle O must be equivalent to 180 degree. Let N1 and N2 be the normals drawn when the incident ray touches the prism and when the emergent ray goes out of the prism at the point Q. Then from the triangle OPQ, angle R1 plus angle R2 plus angle O must be equivalent to 180 degree. That is, sum of all the angles in a triangle is 180 degree. In the triangle DPQ, we know angle delta, which is the angle of deviation, must be equivalent to angle I minus R1 plus angle E minus R2. Here the exterior angle theorem is applied. That is, exterior angle delta must be the sum of the two interior angles or alternate interior angles, or delta is equivalent to I plus E minus R1 plus R2. From equation 1 and 2, we can write angle A is equivalent to R1 plus R2. Substituting for R1 plus R2 in equation 3, we get delta is equivalent to I plus E minus A, or I plus E is equivalent to A plus delta. Sum of the angle of incidence and angle of emergence is equal to the sum of angle of prism and angle of deviation. Hope you have got a basic idea about refraction and refraction through a glass slab and also refraction through a glass prism. Thank you, dear students.